One of the overall themes I'm going to have in both these presentations is that Superpave is dense graded mix. It's 341, it's 344. There's some differences, compactor, little differences in specs. They're both dense graded mix. So when Robert talked to me about this and I was asked and said, well, okay, I'm in construction, what would you like me to talk about? And he said, well, tell us about your experiences with Superpave construction. I cut my teeth in the quality department working up in the four-state area for a company called Matthew Construction. We did Superpave work in Wisconsin, Iowa, Michigan, and Minnesota. When I first started working in the lab at the University of Wisconsin as an hourly employee working for a grad student, first thing I ever did with asphalt was compact it in a Superpave gyratory compactor, and that was in 1994. I didn't learn Marshall until after that, and as soon as I learned Marshall, and then hammers banging away 75 times, you flip it over and bang away. Why is anybody doing this? That other machine, all I got to do is stick this mold in there, hit the button, go have a cup of coffee. So a little bit of background. I've had experience in Wisconsin. I was there with Matthew when we switched hard from Marshall to Superpave practically overnight. December 31st, we were doing Marshall mixes. January 1st, we were doing Superpave. So I'm going to talk a little bit about my construction experiences with those and also a little bit about design too. I'm going to get more involved a little bit in materials when I speak at 4 because I got a half hour rather than 15 minutes. 341 and 344 are not very different. I mean, they're essentially the same type of mix. You don't have a lot of options as a designer on what type of mix you're going to make. But yet there are differences, and there's enough differences that the state is basically saying, all right, we're going in this direction. We're going to Superpave, we're going to 344. So mixtures designed with Superpave. Really, those are the 5 mix types, and Darlene talked about SMA, Mike talked about Tom. Those are both up there, and PFC is up there as well. All of those mixes can be designed with Superpave gyratory compactor. So essentially, we're making Superpave mixes right now under that aspect that we're using the Superpave gyratory compactor. The dense graded mixes are that red line right there. Well, I must be really nervous. That thing's just shaking like crazy. And that brown thing right there, that one down there, also a dense graded mix. Both can be made in Superpave compactor under the 344 spec. This one that dived down here down to 0, that's the PFC, your open graded mix. And then that one right there is your SMA. And then that orange looking line is a Tom mix. And actually the Tom mix doesn't even quite fit on that chart because actually the max density line for the Tom should start right here. And it would look more like an SMA gradation because it is more gap graded actually than open, in my opinion. But for whatever that's worth. So there's 2 types of dense graded mixes you can basically make. You can make them in a Texas gyratory. You can make both of them in a Superpave gyratory. One is the dense graded coarse. Now this is where Superpave tends to get a bad rap in Texas because the original architects of Superpave intended the mixes to be made like this. And the reason for that is that at the time, this was before polymer modified asphalt. This was before high amounts of recycle, and there was a big rutting problem in the nation. And so they said, we want that, which is what is commonly referred to as stone-on-stone contact, so that we can resist the rutting. And so as time has evolved, people have said, okay, we've got polymer modified asphalt, we got recycle, we got these other things, we can kind of get away from that. Because these mixes can be problematic. They can be problematic in construction, definitely, and it can be very problematic in design and control through the plant. You can make that kind of mix in a Texas gyratory, and you can make it in a Superpave gyratory. It's coarse graded. The big rocks and the little rocks kind of work together to make the mix and actually support the traffic. And you do have some coarse aggregate contact. So that's where this, you see some of the big rocks are kind of in touch, and that's where the stone-on-stone contact part of that comes up. When I was at Matthew, we designed a few of these. Like I said, they were difficult to work with in the plant. Could be difficult to compact in the field, but primarily we based all our mixes on traffic counts, or ESLs. So these were the mixes that we were designing for our E10 and our E30 mixes. I don't think actually we had any traffic in Wisconsin that actually met 30 million ESLs over a 20-year design. But we did have some 10s, and we would try to favor these because they held up better under heavy traffic. They're not widely used anywhere in the country. Again, medium and high volume roads are typically what they're used on, mostly on surface, sometimes an intermediate. About the same amount of asphalt, maybe a little more depending on what your VMA ends up with than being on the dense side of that max density curve. Definitely can be more difficult to compact. you're getting closer to what an SMA is when you're going down below that maximum density line. And anytime you do that, and the further away you get it from that max density line, it's going to be more difficult to compact. And also, you remember the old thing, you probably remember way back when Superpave first came out, we had the restricted zone, and that eventually became the reference zone. The restricted zone was created for these mixes. And if you are going down below that line, you don't want to come back up into that reference zone. What the designers of Superpave realized is that at the time there was a lot of contractors who would use a lot of natural sand in their mixes. They'd sand up the mixes to help get density and to help workability of the mix. When they did that, it really hurt stability, and they would end up with a lot of rutting problems. So definitely with this type of mix, you want to stay out of that reference zone. The other thing that's commonly here about Superpave is it's tender. It's a tender mix. That, again, is another aspect of these dense graded coarse mixes. They have a likelihood of being tender. But my experience with tenderness is it's really a gradation thing rather than being a Superpave thing or a Texas gyratory thing. You can make a mix that's tender based on how the aggregates are going to pack with one another and how they're going to move past one another. We've made mixes down here that have been tender. We made some adjustments to them, and we got them untender. But you can have a dense graded fine mix that's tender. I was working on a project one time in St. Louis, brand new mix that they had just made. It was on the fine side of the curve. That thing moved more than, that thing moved more than, I don't even know. It moved more faster and more than an F1 race car out on the track. There's nothing they could do to get that thing to compact until they finally had to drop the temperature almost down to 200 degrees and get out of the tender zone before it would finally stiffen up where it could get some density. Other than that, it was just shoving all over the place, back and forth, and it didn't really matter. So if you do have a mix that is tender, basically what the contractor do is, well, for one, get off of it. Don't bother even trying to roll it if the mix is tender. And then secondly, you got to get off it and wait for it to get out of that tender zone. Sometimes you can hit it when it's hot, very hot, and be out of the tender zone. Most of the time, you have to wait until you're actually cool enough that you're out of the other side. And if you're on it in a tender zone, shoving and actually sometimes even cracking can occur. Another thing about these mixes that we did in construction up there that we found is that you could use pneumatics and breakdown on them. Actually, pretty commonly that's what we did. Sometimes we'd take two pneumatics, put them up front, get our release agent on the tires, get them heated up, put aprons over the tires, keep the tires hot, and the pickup wouldn't occur. And it was very effective on getting some initial density actually by putting pneumatics up in the front on these things, if we were using pneumatics at all, which we typically didn't do. The other thing about these mixes is that number 8 sieve right there, and there's not a lot of control sieves in Superpave. I mean, you have the 8 right here. Actually, there's some on the 4, but the 4 sieves, or the 4 control points are so wide you could drive a battleship through them, so I didn't even bother putting them on there. And then this up here is just gradation size definition. But that point right there is actually pretty critical. Our experience was you always want to stay about 3% above that point there on the low 8 sieve if you're designing one of these. And the reason for that is you get down too close to that lower limit on the 8 sieve, and the mix is definitely tended to be tender, or exhibit a tender zone. The other thing right there is, the restricted zone or reference zone would be right in this area. And so that's what designers were talking about. They didn't want to see a mix that came down here, arced back up into the reference zone, and then came down back low. That was bad news. So now the other side of it, dense graded fine. Again, we can make these in 341, and we can make these in 344, either way. They're fine graded. The big rocks actually in these float around. And they're kind of like big rocks in concrete. They're just there to take space, make the mix cheaper. If I didn't have those big rocks in there, and there was nothing but fines in there, for one, I couldn't get gradation. Secondly, my asphalt content would go way up, and my mix would get a lot more expensive. Kind of see what these Darlene and Mike were talking about with the fine Tom, and the fine SMA. Asphalt contents are going up because they've taken a lot of these big rocks out and just put a lot of more little ones in there and generated a lot of BMA. Little to no coarse aggregate contact. It's not meant to do that. Big rocks are just there to fill up spaces. And the load is definitely carried by the fines. That's why it's very important to have actually some angular fines in your screenings or your man sand, and things of that nature. And that's typically what your dense graded fine mix looks like. Now we're completely on the other side of the 45 curve. So we're staying up here above it and pretty much down till you get about the 50 when you cross over and hit your 200 down low. These have very wide use throughout the country. just not here in Texas. Very wide use throughout the country. Your types A, B, C, and D, the alphabet soup of mixes. That's what these are typically. These are your fine graded, dense mixes. Typically, the use of Superpave in 344, you're going to see about 0.5 to 1% more asphalt in these. And like I said, I kind of talk a little bit more about that at materials, but it has to do with the VMA and the requirements of the specifications. And then also, this one is going to have a 1% higher in-place density requirement. You got to meet a 92 on a 344 versus a 91 on a 341. So you're getting, my estimation, from an agency standpoint, you're getting a better mix. Because it's been proven through studies in many years that the better you get density in place, the better durability and life you're going to have out of that pavement when it's opened up to traffic. So with 341, the use of a pneumatic roller is required. It's still one of the method things they've kind of left in the 341 is you have to use pneumatic. But with 344, I really don't think you need one. Again, having cut my teeth up in the upper Midwest and having had the privilege of working with contractors throughout the country, pneumatic use is just not that wide. Most of the time people have 2, 3, or 4 steel wheels on there. But the difference is that 0.5 to 1% asphalt really does a lot to help negate the initial cracking that you may see under a steel drum roller and breakdown that you don't have to knead back together with the pneumatic. So, like I said, it was very unusual for us to actually use pneumatic rollers in some of my previous lives because we could get the density with 2 or 3 steel drum rollers, all vibrating, and didn't have the cracking type issues. Even a lot of times when I had to get an extra 1% or 1.5% with my finish roller in the very end, I could usually bang the heck out of that mix, even if it got down below 200 degrees, and I wouldn't crack it. Now, a lot of that has to do with that extra 0.5 to 1% asphalt. And another thing, once you're not going to use your pneumatic, it's probably better just to park it back in the shop rather than let the brakes fail and run downhill and run into a pickup truck. Luckily, the guy was not in the pickup truck at the time that happened. One of the things to look for in this is kind of I just throw this out there because it's kind of a thing a lot of people don't know about, especially some of my guys that even don't look at the mixes this way. But on these mixes, that part of the gradation is what controls it. Again, if you remember back to the other thing, the big rocks are just floating around. So these are the big rocks up here, don't really have a lot of say-so in what's going to happen to VMA and asphalt content. This part of the curve right here, specifically that part, is where the voids are created, and this part fills them. So actually, that's one of the things you got to watch for. If I need more VMA, I got to get this low part up higher, and I got to make sure that that part here doesn't follow it, because if it does, whatever voids I'm going to create, it's going to fill up with dust. And so that's how one of the ways you get your VMA on these mixes. So somewhat they're a little easier to control because I don't have to worry about this too much, as long as I don't mess up and get the thing out of alignment on the top here. Again, get my control down here, and typically can make those things pretty consistent. That's a 341 that is here in Central Texas, and that is a Superpave mix, not in Texas, actually from another state. Can't really see they're kind of small, but it's kind of dry looking, harsh. Where this, much more finer mix, and definitely I think you can tell in those pictures it's got more asphalt in it. So, construction, you shouldn't see too much differences between 341 and 344. I mean, if I'm out there, typically I'm not going to see too many differences where I have to have a different paver or a different crew or even different rollers. Now, I may have to have some different roller patterns, and I might even have some different rollers. Like I said, I might have the opportunity to take a pneumatic off and maybe even go with just 2 steels to get density. But really, you don't need to train new people, don't need to get new pavers, anything like that. It's not like all of a sudden you need to get a spray paver or something of that nature. It's, really I don't think you're going to see a lot of differences in how people construct these things. In design, definitely going to have the more VMA. One of the overall issues on a Superpave, and I believe this firmly, our mixes in Texas, our dense graded mixes, are dry. I mean, the first time I came down here over 10 years ago, I started looking at some mixes, I'm like, this mix is dry. People would be like, no, it looks fine. And I'm like, no, this mix is dry. And like, well, this is normal. Our mixes, especially and I hate always comparing to Texas to other states, but you go across the Sabine River, you go across the Red River, you're typically going to find at least 0.5% more asphalt mixes. And that's, I think, one of the reasons why the push is on to go from 341 to 344. Get more VMA. We can only fill up VMA with two things, air, asphalt. And now will give us more asphalt. So the last thing I want to talk about, is, I think this is my last slide, is this is actually two mixes that we have out of one of our plants. Same plant. They're both Type C mixes. And that first one is our 341 Type C. As a Type C, I hate that mix. It's dry, it's harsh. It actually tends to be kind of difficult to compact. I'm actually working with some of the guys right now, and it's like, we got some room that we can maneuver up here. I'm like, get that thing off the density line. You know, the density line basically is your maximum theoretical density line. If the gradation falls on the density line, theory is that's the smallest VMA, the least VMA that you're going to be able to get. That 14.2, that wouldn't make the 344. It'd fail that, makes it 341. And actually, I don't even believe that number. I think that number is probably actually closer to 12. But we kind of measure VMA here in Texas in a goofy manner. That's a discussion for another day. 4.9 asphalt, 14.2. That's our 344 Type C. I have the exact same plant, exact same aggregates, nothing's different. Except now I got 5.4 asphalt, and that one I got 16.1 VMA. That is a better mix. In my estimation, that is a better mix. And I think that's a better mix for y'all, even though you're going to end up paying a little bit more for that. So here's the big thing. If we keep specifying this, that's what my managers are going to push me to give. Because if I'm trying to bid that, and my competitors are all bidding that, I'm giving up $2 a ton, just on asphalt. And 50,000 ton job, that's 100,000 bucks. And I've seen a lot of jobs that people have won for a lot less than $100,000. So that's one of the things, you know, I would say to you guys. The 344, I mean, I'd say it's all up to you, because I'm advocating as much as I can. But at the end of the day, if we keep specifying that, that's what we're going to get. If we want that higher asphalt and that higher VMA, we've got to start moving in that direction. I truly believe that. And let's see, you know, one other thing I wanted to say about all that, I don't even remember. Oh well, could have been that important. So, oh, I remember. Actually, this mix right here, you can see, doesn't even pass the Superpave C gradation. It misses right there. So actually, this mix would fall under a Superpave or 344B. So the max density line would move out here, and it would more like this. Actually, that would be a really good B mix. And that would be a B mix I'd be proud of, because I'd have 4.9 asphalt, 14.2 VMA, and a B mix, which is pretty good. For a C mix,